to friends, students, and enthusiasts. Welcome back once again to my project series. I've come up with a new topic or new project on IoT, that is smart solar power management system with weather-based generation control and mobile dashboard, with a mobile dashboard. Right, so this is the project. Now we'll go to the next slide. Okay, first of all, abstract of this project. This is an IoT project, please remember, where I have used ESP32 because it's an IoT, so I need a wireless communication. And solar power generation, storage, and distribution. Okay, it will be stored in a battery, solar power. I have used the smaller solar power and dynamically adjust energy routing based on weather condition. That means you can control the load, because looking into the power, voltage, current, and power and intensity of light, you can decide what loads is to be switched on or switched off. That control will be there on the dashboard. All right. Display live, it will be showing on the your web dashboard, as well as I have used a small LED LCD also, okay, where I will be showing you that also. The key features are solar power monitor, monitoring measures solar panel voltage current, battery management, that is, it will give you whether the battery is charged or not. Of course, that part I will, we can write codes for that. Weather condition integration, that is temperature and humidity. Predicting the LDR, that is it according to light, and it will predict. Predict means what? If you are using artificial intelligence AIML, at that time LDR and DTH values will be very, very important. Okay, so next is load control, that is automatically switches on essential load on off based on available power. Mobile dashboard, real-time monitoring through a smart browser, that is acts like a Wi-Fi server. Data logging, historical data, stores the ESP memory, can be expanded with SD card. If you are using an SD card, we can put an SD card. We have to log, then we can store the data. When it can be done, when you are using a tiny AIML for that particular purpose. That is automatic system. Whether prediction will be there, where it will take the reading from the LDR and DTH. Okay, anyhow. The components, what I have used it, you can see in the picture, these are the main components. These are ESP32 is the main board, solar panel. Okay, any solar panel for this thing, it is given 10 to 20 watts, depending upon your project size, and you can lithium-ion batteries, charge controller. That is, if you are running the complete circuit on a charging this thing, then you can use TP4056, that is 5-volt MPPT module, or any other MPPT module. Voltage and current sensors, that is, here I have used an AC712, and for voltage sensor, this is a current sensor AC712, but voltage sensor I have just made it with the help of a resistor by balancing two resistors from supply and ground. Okay, so I will show you that also. Okay, so value according to that you have to decide. LDR light dependent resistor I have used, DST11 I have used, you can use DST22 also. Two LEDs instead of the relay. Okay, here I have shown the relay, but I have used the LEDs just for making sure, because the relay and all, again, for making you understand this thing, it will be difficult. So very simple circuit, you can use two relays to control the load. Okay, OLED display, that is 0.96 I2C local data display. We can add more sensor to this. What sensor? We can add rain and other sensor also to this, because it will give three options. That is temperature, humidity, rain, and light. Right? Okay, but I have not used it in this. I'm just giving you the idea of it. Working principle, data collects, ESP32 reads the data, and solar panel voltage current available generates the power. Battery voltage, that will store it will charge the battery current, and current charge, charging, discharging status it will show. I've not given a charging, discharging status here, but it will show you the current and the voltage both. Okay. And third parameter is your power also. How much power is consumed or generated? Whether data, light intensity of light will be there, and temperature and humidity, of course, it will be there, right? Algorithm, if you want, you can just put the sunlight and cloudy, rainy, all these algorithm you can put if you are using an AI, right? User interfaces, ESP32 host a web dashboard accessible via mobile browser, display solar power, battery status, not battery status, battery voltage, weather and load status. Okay, allow manual control. So that is two buttons will be there for control. So display already shows power battery, not percentage, voltage and load status locally. Tiny ML model integration for solar power prediction and use it to optimize load control. We can add this thing in a tiny ML model that for if you want to make a AI based. Okay. So I've not used it AI based right now, but you can add definitely by using the tiny ML data and you can go for it. So this is a simple circuit how the solar panel is connected to ESP32, OLED display, battery, and instead of this thing, we have used the DST11 sensor. I have not shown it here, of course, and the relay load and the other things have been given. This is not the exactly same, but please remember all the details are given in the codes. What connection goes where. I hope you will understand this. If you have any problem, you can let me know and I will give you the complete details about the circuits and the codes. Of course, I'm going to share the codes also with you. I hope you will like. Let's go to our lab. All right, friends, we are in our lab now. So I will just explain you what a power management system with weather-based generation control with mobile dashboard. We can add artificial intelligence also to this, right? So you see a dashboard over here, that is mobile dashboard. You see an OLED screen is working where you are getting all the parameters. And also from dashboard, we have two buttons over here. I will just try to show it to you. This two button that will control the loads. Here loads I have shown in two LEDs form. Of course, we can use the load in the form like we can use the relay, but instead of relay, we have used two loads. So I will just show you how does it work. You can see one load, right? Then I will tell you I can control the second load also. Okay, right? You can see second load, then the first load, right? Both the loads I can control from this. Okay, right. Okay, and all the parameters that is voltage, current, power, and temperature and humidity, right? Because our panel, that is your solar panel, will generate electricity, that is current and voltage, according to the light which is given. So light, temperature, and humidity will decide how much power will be generated, which will be stored in the battery, and how much, when it is stored, how much output you can provide. And if suppose the generation is less, you can control the load. This is our load. Okay, that is the idea. Okay, all right. So now I will just tell you one by one how I have given the connection and how it is working. So here the solar panel, it is giving connection to my current device, that is AC712. That is my current sensor. I have used a voltage sensor. This is my voltage sensor where I have used two resistor. Okay, this two resistor are for works like a voltage sensor. Voltage sensor, then two LEDs. This is my DST11, and in the corner here, this is my LDR sensor, which will see the light. Here, light is given is it is given light is 2257. That is in lux. It will be given. Temperature is given. That is given. That is taken care by this sensor. That is temperature and humidity. Power is calculated according to the consumption. That is how much power is generated according to current and power. It will be calculated. And voltage and current, with the help of these two, the power will be calculated. So this is very good and smart solar system. where you can use or we can control the load according to our charge which is present in the battery. Okay, so this is a very simple circuit. I have explained you about this thing. Next, how is the codes working in this? Okay, how you get the IP address so that the wirelessly I can come to this particular part. Okay, this particular section. You can see again, I will just, I'm controlling the both this thing. That is when it is low or high. Suppose if you find that the power work this thing, you can close the load, right? You can close the load. That means these two are my relays where I can control the loads, okay, through my application. That is your mobile application. To make this application and all, I will just explain it to you with the help of a codes. Explain you about the code part, right? So here in our code, these five are the library, that is Wi-Fi, web server, WireEdge, and Adafruit, GFX, and SSD 1306H, and also DST library. So since this first part, all this thing I have given you, second part is my Wi-Fi credentials. Okay. Third part, when we come here, I'll just explain you about the third part. That is, I have defined the pins. Okay, the pins which are given the connection. That means the connection to your ESP32. Okay, sensors. That is DST sensor. I have used it here. Okay, about that I have given the connection. That is already it is given connected to pin number 4, and web server, that is it is working on channel number 80, sorry, and ADC calibration, that is when you calibrate it, that is the voltage divider. What is the value you have to give it here so that it will calculate by itself. For that, the complete description will be here. Okay, as well as the sampling current, for the current also it will be there, and moving average temperature and everything, it will be counted in this particular area. Okay, this particular this is the temperature and everything will be counted on this. Then void setup, you have whatever the pins we have given, LDR and all. According to that, it will be resolving the or calculating the complete picture about how it will work. Okay, right now void calibrations. Then you have current ratio. Then you have read battery voltage. And this part, that is this part is my HTML page. That is for giving, I just have shown you for making my application. Okay, so this is my application. Then you have a web handler. Okay, this is my web handler program that is controlling the relays. No, I'm controlling my relays also. So that is come into that. Then temperature is measured in Celsius and humidity in percentage. So likewise, OLED display screens and everything is given here. So finally, the delay time is I've given is 500 seconds, microseconds, sorry. So these are my codes. And finally, when I load this code in I've used ESP32 Do It Development Kit V1. And when you load this program, first of all, I already told you, you have to select the board and the port. Okay, correct port. Then you have to load it. After loading, you will get an IP address. You can see here an IP address. You can find IP address over here. That is, I have got the IP address. And finally, on your mobile phone, yeah, you can see here, I've given the IP address. If you want, we can refresh it again. Okay, I will refresh it again. Right, because the temperature, humidity, power consumption, everything will be changing. Okay, this is my sensor. Here I have kept my sensor. What sensor? Current sensor. Voltage sensor is here. I've already told you. Voltage sensor is here. These are my batteries. I can run this on a battery. Like I'm showing it connected now for just for showing purpose. I've connected to my laptop, but you can run the whole thing. This will charge this, and the whole circuit will run on the batteries. Okay, right. So that you have to understand. All right. Okay. So I hope you like this project. If you have any questions or this thing, please do write to me. Okay. And you can anytime I will send you I will give you the codes also. And you can copy and you can make the project necessary changes.